This demo, we're going to try and create a new part and create a sketch profile that's symmetrical about the absolute axis. Let's create a new part. We'll go to Part Design. Really, you want to make this the in-work object. So when I hit the pad command, I don't get the error. I'm going to use this sketch-based feature profile. And I'm going to select the y-axis as my horizontal line and the z-axis as my vertical line, and select OK. I'll slide this down to the, well, actually this is going to be in the middle of the part, so let's go ahead and go to the Sketch tab and find the rectangle profile. Since I use this feature a lot, I do have this in my action pad, so if you want to learn how to manipulate your action pad, you can turn that on and add, delete stuff out of there and use rectangle from here. So under rectangle, I can just go ahead and create a profile. Let's just do something like this, not perfectly squared. And then let's click off of it and highlight this whole thing under auto constrain. I created a box around this and said OK. Oh, my CATIA is doing something really weird, very slow. Let's try that again. Auto constrain. I'm going to click up here and drag. Of course, I got CATIA doing some weird stuff here. I'm going to select OK. You'll see how slow it's going. Now, I didn't dimension it perfect. I wanted it the overalls. Okay, so what I would do is when you create that rectangle, just go ahead and create that rectangle any size. You notice it's not symmetrical, it's not perfect, but I just go ahead and hit auto constrain and auto constrain the profile so I get it fully constrained. And then I just highlight the whole thing again and then hit auto constrain and say OK. And it will find the axis and dimension everything about the axis. You'll notice it turned green. The green means it's a closed profile that is fully constrained. Okay. Now, dang it, I just happened to make that perfect. I was trying not to. Even when I try not to, I can't help myself. So let's go ahead and change this here dimension to something different. 6. Okay. So you notice this part is not symmetrical about the axis. What I like to do is, because I constrain the overalls, I can take this dimension here and double click it and right click on this and hit edit formula. If I do that, I can select this existing dimension and it will put whatever the name of this offset is, it will add it into this pop-up window here in the input field. So when I click on this twice, double click on it, it adds that. It says right here that this is offset 8 and this is offset 6, and they're now currently going to be equal to each other. But I don't really want it equal. I want it half of whatever this value is here. So all I have to do is at the end here, divide this by 2. So offset number 8, which is this offset here, that's offset 8. When I put my cursor here, that's offset 6. Offset 8 equals offset 6 divided by 2. Select OK. And it'll automatically figure out whatever that value needs to be. I select OK. Again, I'll double click on this constraint, or I can single click it and hit this formula, edit formula. I want this to be half of this, so I double click this to put it into this field. So now in that field, I hit divided by 2, select OK. Now this profile is going to remain concentric because it has an FX here and an FX here, letting you know that it's a formula that it will calculate that for us. So inside my sketch, I have these constraints. Offset 6, offset 7, offset 8, which is half of offset 6, and offset 9, which will be half of offset 7. Which means if I double click on this and change it to 5, this will automatically change to 2.5. I'm trying to move this dimension down. Come on, computer. If I change this 6 to 7, that constraint automatically changed to 3.5 here. I'm going to put this back at 5. I'll put this one back at 5. And you notice that it just automatically continues to hold symmetry. Just for kicks, let's make this a little different size. I'll hit 7. And that is how you create a symmetrical profile in the sketch workbench on the absolute axis. Next, we'll go ahead and make standard solid versus a thick solid.